Good morning, students. Welcome to video lecture on electromagnetic waves and transmission lines. Subject code U18EC403. Topic General solution for plane wave equation. You can refer to the animated image of plane electromagnetic wave. Blue lines are electric field, red lines are magnetic fields. The electromagnetic wave traveling along z direction if the electric field is along x-axis and the magnetic field is along y-axis. General solution for plane wave equation. Equations 1 and 2 are regarded as wave equations. These are del square E is equal to gamma square E and del square H is equal to gamma square H, where E is equal to EXAX plus EYAY plus EZAZ and H is equal to HXAX plus HYAY plus HZAZ. Consider a plane wave traveling in z direction x, y. The field is along x and y. The electromagnetic wave is traveling in z direction. For a plane wave traveling in z direction, it has Ez equal to 0 and Hz equal to 0. Along the direction of propagation, the field components are 0 and dou by dou x equal to 0 and dou by dou y is equal to 0. General solution for plane wave equation. Continue. From equation 1 is del square E is equal to gamma square E. Equation 1 can be expanded as dou square E by dou x square plus dou square E by dou y square plus dou square E by dou z square is equal to gamma square E. Let it be equation number 4. And from the properties of electromagnetic wave traveling in z direction, it has dou by dou x equal to 0 and dou by dou y is equal to 0, and hence these two terms becomes 0, and equation number 4 can be rewritten as dou square E by dou z square is equal to gamma square E. Now by expanding equation 5 E is equal to EXAX plus EYAY, where Ez is equal to 0 as the electromagnetic wave is traveling along z direction. Along the direction of propagation, the field component is 0. Now by equating AX and AY terms in equation 6, we get dou square EX by dou Z square is equal to gamma square EX and dou square EY by dou Z square is equal to gamma square EY. These two equations are very important in writing general solution of electric field in x direction and in y direction. Now for equation number 7, taking x component for solution for a plane wave traveling in positive z direction. Here in this case we are considering the electromagnetic wave traveling in positive z direction. The general solution of equation number 7, that is taking x component for solution for a plane wave traveling in positive z direction, can be written as Ex is equal to Ex of z. Ex of z means electromagnetic wave x polarized traveling in z direction. Ex naught is the magnitude e power minus gamma z. The electromagnetic wave traveling in positive z direction indicates minus gamma z. If the electromagnetic wave traveling in negative z direction, then here we have to write e power plus gamma z. Let it be equation number 9a, and taking y component for solution for a plane wave traveling in z direction, the general solution of equation number 8 can be written as Ey electromagnetic wave y polarized traveling in z direction is equal to Ey naught positive z direction e power minus gamma z. Similarly, for magnetic field, Hx of z is equal to Hx naught e power minus gamma z, and Hy of z is equal to Hy naught e power minus gamma z. Once refer to the equations 9a, b, c, d. Multiply equation number 9 with e power j omega t, and by taking the real component, it does not affect the general solution of the plane electromagnetic wave. From 9a multiplied with e power j omega t and taking the real component, this can be written as Ex of z comma t Ex naught e power minus alpha z cos omega t minus beta z plus pi x. In some cases, we exclude pi x. Let it be equation 10a. Here gamma is equal to alpha plus z beta e power minus gamma z e power j omega t, and its real component can be simplified as e power minus alpha z cos omega t minus beta z plus pi x. Here pi x is the phase of the electric field along x direction. Ey of z comma t Ey naught e power minus alpha z cos omega t minus beta z plus pi y. The pi x and pi y will provide the information about whether it is linearly polarized or circularly polarized. We are going to discuss the polarization concept in the next class. If you observe the general solution of 10a and 10b, Ex naught and Ey naught are the magnitudes along x direction multiplied with e power minus alpha z. Means after traveling some z distance, the wave amplitude attenuated by the factor e power minus alpha z, and cos omega t minus beta z. Omega is the frequency of the electromagnetic wave, minus beta z implies the electromagnetic wave traveling in positive z direction. Similarly, for magnetic field components, Hx naught e power minus alpha z cos omega t minus beta z hy of z comma t, hy naught e power minus alpha z cos omega t minus beta z. Let it be equations 10c and 10d. Once again, refer equations 10a, b, c, d. These equations are a general solution of plane electromagnetic waves. In the next slide, we are going to rewrite the equations 10c and 10d, the hx naught and hy naught terms in terms of electric field components and intrinsic impedance. The intrinsic impedance is represented by eta at angle theta subscript eta. The intrinsic impedance is equal to root of j omega mu by sigma plus j omega epsilon. It depends on the type of the material, and we considered an electromagnetic wave traveling in z direction. So Ex by Hy in clockwise direction it is positive, and Ey by Hx in anti-clockwise direction it is negative. Ex of z comma t x naught e power minus alpha z cos omega t minus beta z plus pi x. In some of the situations we exclude pi x and pi y. Now equation 10c, x of z comma t, here the term present is hx naught. Hx naught can be replaced with ey naught by minus eta minus ey naught by eta at angle theta. Here you can exclude the term theta by inserting into the cos. 10c can be rewritten as 10e and 10d. Here the term present is hy naught ex naught by eta. The angle is in denominator, so it is included in cos term with negative sign. 10d can be rewritten as 10f. You can use 10abcd as general solutions, or 10ab and ef as general solution of electromagnetic wave. Summary: del square h is equal to gamma square h. Del square e is equal to gamma square e. These are the wave equations, and the general solution of wave equations are Ex of z comma t is equal to Ex naught e power minus alpha z cos omega t minus beta z plus pi x Ey of z comma t Ey naught. You can exclude pi x term in some cases. Pi y term also can be excluded in generalized situations. The general solution of Ex, Ey, Hx and Hy, and along the direction of propagation Ez is equal to 0 and Hz is equal to 0. That is the summary of General solution for plane wave equation. Once refer to the other biography. Hermann von Helmholtz derived the wave equations. James Clerk Maxwell suggested that the field would travel with a speed of light. Thank you. We will meet with the next lecture.